I'm Dave Catlin, and this paper is on the use of educational robotics research to transform the classroom. It's also about establishing a community of evidence-based practice using the MESH guides and the tactics framework. I presented this paper on behalf of my co-authors Andrew Chismadia, James O'Meara and Sarah Yoni at the Robots in Education conference held in Switzerland in 2015. Most educational research doesn't actually make an impact on the classroom. Now, the MESH guides are designed to change that. It's about getting that research to affect the classroom, and importantly, it's about getting good classroom practice to affect research. What this presentation is about is how we're applying that to the Roma educational robot. In the course of doing that, I'll come across a number of issues which I think are important to the future of educational robotics. I want to start with a question, and as it happens, this question was asked yesterday in the workshop. We're all doing educational research. We are all coming up and finding advantages of educational robotics and pitfalls of educational robotics. Is there a commonality between what we're finding? Is there a theory of educational robots? I need to give you a little more of my personal biography. I started developing educational robots in 1983, starting with the Valiant Turtle, then what is now called the Classic Roma and the Roma. In that 30-odd years, I've worked with thousands of teachers. I've sold hundreds of thousands of robots. I've been in innumerable classrooms on 5 different continents. I've been in some of the richest schools in the world and some of the poorest. Over the decades, I've accumulated a lot of experience, got a lot of research results, and pretty much all of that was locked up in my filing cabinet. In 2010, I decided to make it public. I got together with Mike Brewer-Mayers from Canterbury Christchurch University, and we wrote the paper on era principles, which we presented at the Constructionism 2010 conference in Paris. Now, these principles, or 10 of them, are answering that question. I'm not going to try in this paper to explain the era principles, but just to give you a flavour, this is the sustainable learning principle, which is essentially saying that with educational robots, the students don't just learn content knowledge, it's a much more holistic process. They acquire skills through the way that they work with the robots. They acquire skills which are sustainable learning skills, also known as lifelong learning skills. And you see on this that we break them down into 4 essential areas: cognitive, social, emotional, and personal. Another starting point occurred in 2001 with the launch of the No Child Left Behind Act in the USA. This mandated that educational interventions had to be founded on scientifically based research. And a caveat came along with that, stating that federal funds could not be spent on the initiatives that did not meet these strictures. Now, according to the definition being used, most of the research we as a group would not pass that standard and therefore would not be eligible for funding. This idea has now reached the UK, and in itself it's not a bad idea. The problem lies with what is considered to be scientifically based research. This is a model being used, and it's taken from the medical profession, and we see at the top random control trials. These are the proposed gold standard. Everything below this is somehow considered not quite good enough. Even the term quasi-experimental implies a feeling that it's a little bit substandard. Does a pen or a book work as an educational intervention? They are tools and they work if used appropriately. And I believe educational robots fall into this category. And I've often said that there is enough research in one educational robot activity that somebody could earn a PhD. Well, last year that happened. Dr. Stephanie Holmquist from the USA earned her PhD for for the study of a single Roma activity. Coming back to this slide, we see the problem. In medicine, it is the massive international drug companies doing this random control type work and spending billions of research dollars doing it. Education research is really not in that league. You also notice, as experts in educational robots, our knowledge is classified here, down at the bottom. Worse off still are teachers whose practical experience is by necessity expressed as anecdotal evidence, and it was certainly dismissed at the meeting that launched SBR in the USA. In my view, this top-down dispensing of wisdom is flawed. Mike and I addressed this issue in the Darmstadt Education Robot Conference in 2010. We delivered a paper called the E-Robot Project. Now, the problem with anecdote, of course, it is an individual experience and an individual opinion, and there's no way of really telling how general it is. Well, we don't believe that's the case. We believe that now we've got the web, that we can utilize the web to gather people's experiences and see how general these experiences are. We are not anti-random control trials. We are anti-gold standard. We believe in a more holistic approach that is done in practical, normal classrooms. And we believe that if we can gather, say, like 1,000 teachers from completely independent of each other, come to the same conclusion, then those results are significant. ERA provides us with a research hypothesis. I illustrate this with the embodiment principle, which is essentially saying that there is at least a qualitative difference in a student's experience with physical robots compared with virtual robots. Yet the evidence for this is not very strong. It consists of AI theories of embodied intelligence, some ad hoc surveys I've done with experienced Roma users, and some mathematical theories on how children develop their spatial awareness using microspace, which is what the computer screen is, mesospace being where the robot runs around in the room, and macrospace, which is the city. Now this is important to us. In England, they follow the US idea of wanting interventions supported by evidence. The recent Sutton report states that there was only weak evidence for some of the common interventions used in English schools, and this provoked a reaction in the press, which said trendy teaching methods don't work. We want to avoid that. Of course, it's not that they don't work, it's just that we don't have any evidence that they work, and that's a different story. So we need to gather evidence to prove that robots work. Another ERA principle is the curriculum and assessment principle, which states that educational robots can facilitate teaching, learning and assessment in traditional curriculum areas by supporting good teaching practice. The key phrase here is good teaching practice. What is it? The answer to this lies in a formative assessment approach called the Assessment for Learning, or AFL. This is work done by Black and William from King's College London in a paper called Inside the Black Box. The classroom is the black box, and traditional assessment measures what you put in and what you get out. AFL is concerned with what goes on inside the classroom. How does the teacher manage the classroom? How do they cope with the sorts of imagination and inspirations that educational robots evoke? and yet still stay focused on delivering the curriculum. Before I move on, I want to emphasise that AFL is really a codification of good practice. 10 years before the Black Box paper, a national turtle project involving 350 schools in 21 school districts demonstrated that work with robots had a natural affinity to AFL ideas. I've written 2 papers on assessment for learning and educational robotics. Now, AFL has 4 elements. The first of these is learning intentions. This is not the same as lesson objectives. The important thing about a learning intention that it's in the student's voice. It's not something you just write up on the blackboard for them to repeat like a parrot. And you can really only establish learning intentions when the students are engaged in the activity and they're aware of what they are learning. Not what they're doing, but what they are learning. Alongside learning intentions and success criteria, this again is in the student's voice. It's about them understanding when they've been successful. And this is very natural for educational robotics. An example, we do an activity where the students make the Roma into a dog. Now, it's never going to be a dog, but in the student's mind, it's when they've achieved success. This is their dog. Now, of course, it's important for the teacher to keep the standards high and to push them. They can't just let them get away with anything. The other thing, of course, is the quality interactions and feedback. This is such a natural part of educational robotics, and it's such, we've all experienced situations where there are fantastic and concrete and real opportunities to discuss things with children. Educational robotics are very natural for supporting peer and self-assessment. Students are constantly assessing their work and assessing the work of their peers and giving each other feedback. Another factor involved in this, though, is effective questioning, and this is involved all the way through the process. And it's really the teacher's ability, the key teacher ability, to focus the children on what's important and to get them to consider the real issues. For an experienced teacher, all of this is second nature. They come on stage 4 on this skill ladder. When I send out a Roma, it goes out in a little brown box and it can end up anywhere in the world, and I have no idea about the skills of the person who's going to receive it. Often it's a non-teacher, like a teaching assistant, a technician, or a parent. So what I have to do is to build into each activity training that allows people to gradually acquire these skills. It's not just teaching skills that are required. The teacher also needs to be able to use the robot effectively. This diagram illustrates the training dimensions that need to be addressed. It is important that we provide activities which are beginner friendly. In the past, particularly with Logo, teachers were presented with an overwhelming program manual. This didn't work. This brings us to the critical thing, activities. Activities are the thing that links the technology to the student's learning experience. And I want to introduce tactics. This is a framework which defines the elements required to present teachers with activities which meet the curriculum needs, and at the same time set up a mechanism where the evidence informs the practice and the practice informs the evidence. These are the elements of a Roma activity, and while we developed them before I knew about the tactic framework, certainly tactics helped us to refine them and focus them a little bit better, and I would now describe them as being tactic compliant. Any well-trained teacher should be able to look at the activity page and do the activity without any further information. Not all teachers are experts, and some people need extra support, and that we give them a lesson plan which is step by step. Now this is dangerous because it makes the activities look prescriptive, and that's not what they are. They're meant to be suggestions and ideas. It's meant to be an inspiration. Teachers are free to change the activities and adapt them to their particular needs. If you cook, you need to think of this as a recipe. If you're a great chef, then you'll look at the recipe for inspiration. If you're a reasonable cook, you'll look at it, remind yourself about things, but you'll do variations of it to suit your particular taste or what ingredients you have. If you've never done the meal before, you'll probably follow it step by step. But once you've done it a few times, your confidence grows, your skills grow, and you then start doing your own variations. So the way you design the page is quite critical. Here we see that the information is presented. You get headings, you get the main tasks, you get details that are quite distinct. You can quickly scan this page and get the main points. And if that's all you need, you're done. If you need more detail, it's available. The whole aim here is to provide something that the experienced teacher can quickly read and use. And yet you want to support the novice. Now the electronic format is ideal for that. Back to our recipe analogy. If the recipe says something like add the whites of 2 eggs and you've no idea how to separate egg yolk from their whites, then you have to go find out. That makes it just a little bit harder and you're a little bit more reluctant to do the activity. Now that's the beauty of electronic formats, because you can use pop-ups, and that links you to the training materials, and anything you need when you need it is instantly available, but it doesn't cloud the thing for experienced users. They can just read straight through the technical bit. Next is the teaching notes. Now this has a lot of information about the subject, the topic, what children need to know before they try and do this activity, links to the training side, specific hints and tips, and even the science of learning and references. Now you may think that this is a lot of information, and given all the other stuff, that's far more than you get with most activities. Is this necessary? Well, the fact is that over the years people have asked for this kind of information. Nobody asked for all of it, but people ask for some of it, and so it's there available if people need it. Lists of resources and links to them, plus curriculum links, are obvious necessities. The next part brings together ERA, eRobot, and Assessment for Learning. This is an evaluation form where the teacher can record the results of an activity. Teachers don't need extra work, so they have to be able to fill in this form quickly and get some benefit from doing so. Well, it provides them with a record of what the students have achieved and also what they need to do next to improve the students' performance. It provides us with data which helps us to prove the case for educational robots, but also helps us to improve individual activity. This brings us to the mesh guide. Now, how do you collate all this data? We've got information going back into the mid-60s. How do you make sense of different children, different age groups, different countries, different abilities, different topics? What we need to be able to do is bring all of that together, and this is what the mesh guide does. It provides us a framework for collating and presenting information to people. This provides data for the eRobot project, whose aim is to provide proof to the public, to teachers and the government about the value of educational robots. In conclusion, the mesh guides and the tactics framework provide useful tools for resolving problems identified in the eRobot paper. They have been used to modify the organization of the Roma activity library and set up a situation where continuous gathering of information from practicing teachers on the effectiveness of educational robots expressed by the ERA principle is possible.